In this lesson, you will learn to extend the meaning of exponents to include rational numbers. So up to this point, we have learned how to use exponents in many different contexts. We have learned how to do regular exponents. So like 4 squared means 4 times 4, which would be 16. We have learned 4 to the negative second power would be 1 over 4 squared, which would be 1 over 16. And we've dealt with 0 exponents. So 4 to the 0 power would be 1. And anything to the 0 power would be 1. So we've dealt with positive numbers, negative numbers. We've dealt with the number 0 for exponents. Now in this lesson, we're going to expand so that we include even fractional exponents. So for example, here we have 16 to the 1/2 power. And it's kind of hard to tell, but it's not times 1/2. 1/2 is your exponent. So how this works is basically just pattern recognition as far as learning or remembering how to do this. What we do is we take the numerator and we put it with the 16 inside of the radical. This 2 is going to be your index for the radical. So we can convert any rational exponent into a radical expression. So the numerator goes here and the denominator goes as your index. So then we can take the square root of 16, which would just be 4. And that is my solution. So if you remember the pattern, you can answer any type of question with any exponents. Here we have 9 to the 1/2 power. Same thing, we create a radical sign. This 1, the numerator, goes with the 9. The denominator is going to be your index. So what I have is going to be the square root of 9, which would just be 3. And by the way, if you have a 2 for the index, that is an assumed square root. So we do not need to write the 2 in your expression. It could just be the square root of 9 like you see right here. Here's another example where you have 2 to the 3/4 power. And you're told to write this using radicals. Well, what I can do is I can write the radical sign, put the 2 on the inside, and the numerator, the 3, will be your exponent with the 2. So inside you have 2 to the 3rd power, and then on the outside your index is going to be the 4, the denominator. So your solution would be the 4th root of 8. Let's look at a few more examples. Here we have 4 to the 3/2 power. So once again, we can write this with a radical. So we have a radical sign. The 4 will go inside. The numerator, the 3, will be the exponent with the 4. And then the denominator, the 2, is going to be your index. So now we have the square root of 4 times 4 times 4, which is 64. And the square root of 64 is going to be 8. And actually, there's another way that you can think of this. So not only could you put the 3 right here with the 4, we could also put the 3 outside. So basically what we're doing is instead of cubing first and then taking the square root, we can take the square root first and then cube the square root. So here, if we take the square root first, we have the square root of 4, which is 2. So we have 2 to the 3rd power, which is going to be 8. So either way, we get the same solution. And there's times when this first method will be easier and times when the second method will be easier. So here's another example. We have 27 to the 1/3 power. So once again, we can write a radical sign, put the 27 on the inside. This 1, the numerator, goes with the 27. And the 3 is going to be your index. So what we have is the cube root of 27, which is going to equal 3, because 3 times 3 times 3 is 27. Now look at this next one that's similar, 27 to the 2/3 power. So like we said, we can write this 2 different ways. We could put the 2 inside with the 27, or we could put the 2 on the outside and do the cube root first. So notice this first method, if you do the squaring first and then take the cube root, that's not going to be a fun one to solve. But if you take the cube root first, we can do that very quickly because the cube root of 27 is 3. And then we have 3 squared is going to give me 9. So notice the second method is easier in this case. Now here are 2 more examples, and then we'll move on to the next part of the lesson. Here we now have negative with a fraction. So remember, negative exponents means that you have 1 over and then 25 to the positive exponent. So 25 to the positive 1/2 power. So the negative exponent means 1 over something. So 25 to the 1/2 power is now in the denominator, and we can write that using radicals, where we take the radical and then 25 goes on the inside. The numerator goes with the 25, and the 2, the denominator, is going to be your index, which is over here. So we have 1 over the square root of 25, which would give you 1/5. And now there's times, such as right here, 4 to the 2.5 power, where it's not a fraction and it's not a whole number, but I can convert this into a fraction. So 2.5 I can convert to a fraction. We know that's 2 1/2, and as an improper fraction, we take 2 times 2 plus 1 to get 5 over 2 for your exponent. So we now have 4 to the 5/2 power, which I can then write as a radical. Where here's my radical sign. The 4 can go on the inside. The 5 can go either with the 4 or outside, like we have here. And the denominator, the 2, is going to be your index. So we have the square root of 4 to the 5th power. So if we do the square root of 4 first, we'd have 2. And then 2 to the 5th power would be 2 times 2 times 2 times 2 times 2, which would give you 32. So notice once again in this case, if the 5 were on the inside, you do 4 to the 5th power first and then do the square root. That's going to be very difficult to get your solution of 32. Now going back the other way, let's say you're given a radical and you're told to write this in exponential form. So we're writing something like this, where you have the cube root of a to the 4th power b squared over c cubed, and converting that to have exponents instead of radicals. So all we're doing is the same thing that we did in the previous examples, using the same concept. And once again, this is pattern recognition. So how to do this is we just go backwards, looking at each part separately. So a to the 4th, we'll look at that first and say, okay, how do we write a to the 4th power and then take the cube root of that? Well, remember the 4 is going to be the numerator of your exponent. And then the 3 over here is going to be your denominator. So what you have is a to the 4/3 power if you look at just the a part. Looking at the b part, we have a b, the 2 is your numerator, and the 3 is going to be your denominator. And then over, you have c cubed. So we write this as c, this 3 is your numerator, and then the other 3 is your denominator. So then just simplify your denominator of the big fraction. So we see here we have c to the 3/3 power. You can write that as c to the 1st power, or just c. And that would be my solution for this first example. Now here we have 2 radicals that are multiplying together, and you are told to simplify. Well, to simplify, what you'd like to do is get this into one radical. But notice you have different indices. So that's plural for index. You have different indices, where the first one is a square root, the second one is a 6th root. Now, to combine, I need those to be the same root. So they both have to be square root or both have to be the 6th root. But what I can do is I can convert these into exponential form. So to do that, I'd have 5 to the 1/2 power and then 5 to the 1/6 power, right? Because the first one, you have a 1 and then a 2 here, so it's 1 over 2. And for this other one, we have 1 for your exponent and then 6 for your index. So then from here, notice we have the same base. They both have a 5 for the base. I'm multiplying, so I can add the exponents. So I can combine by adding the exponents, 1/2 plus 1/6, get a common denominator, So we have 3 6 plus 1 6, which gives me 4 6, which can reduce to be 2/3. So I can write this as 5 to the 2/3 power. And then I can now go back and put into radical form, where I have the 5 on the inside, the 2 is going to be your exponent with the 5, and the 3 is going to be your index. So I can write this as the cube root of 25. So notice the strategy there. We converted to exponential form so that we can combine the exponents and then go back into radical form at the end. So now, using that same strategy for this example, this one is not as obvious, but the objective is still the same idea, where I want to simplify by combining these two expressions. In the previous example, we had both of the radicals had the same number inside, whereas here we do not. And we cannot combine into one radical at this point because we have a square root and a cube root. So what I can do is the same thing we did before with one extra step at the beginning, where I can make the inside to be the same base to begin with. So the 8 you can break down as a product of 3 2's, 2 times 2 times 2. The 16 is a product of 4 2's, or 2 to the 4th power. So from here I can write this in exponential form, where I convert this first radical to be 2 to the 3 over, that's a 2, so 2 to the 3 over 2 power. And then the second one would be 2 to the 4 over 3 power. And then now I can combine by adding the exponents. So I have 3 halves plus 4/3. I need a common denominator of 6. So I have 9 6 plus 8 6, which gives me 17 over 6. And that's going to be your exponent. So this one, the instructions say write in exponential form. So this would be following the directions of writing in exponential form. But if I want to go further, like I did in the last example, and convert back into radical form, what I can do is then, from here, convert this back into a radical, where the 2 goes on the inside, the 17, the numerator, goes with the 2, and the 6 is your denominator, and that's going to be your index. So then, one last thing is, notice I could pull out groups of 2's. Because the index is 6, I could pull out groups of 6 items. So I have 2 groups of 6 that I can have. Because with 17, if we take 2 groups of 6, that's going to take 12 of the 2's. And there's 5 left over, which does not make quite a full group of 6. So I have 2 groups of 6 that I can pull out. So 2 groups of 2's. So I have 2 2's on the outside. And I have 5 2's remaining on the inside. So my solution would be 4 times the 6th root of 2 to the 5th power, and 2 to the 5th power you can write as 32. So right here, the 2 to the 17 over 6 would be exponential form. Over here, 4 times the 6th root of 32 would be simplest exponential form. Now I'd like to finish this lesson by explaining how to use this property to solve equations. So here now we have fractional exponents inside of an equation, where example 1, we have y to the negative 1/2 power equals 5. Now when you solve equations, the objective is to get this to be solved for the variable. So we want this to be y to the first power equals something. Okay, well, we want to get rid of this negative 1/2 and convert it so that we have just a plain old y to the first power. Well, how do you get rid of the radical? Well, to do this, what I want to do is raise both sides to the reciprocal power. Meaning, here we have a negative 1 over 2. I want to raise both sides to the negative 2 over 1 power, which is the same thing as raising both sides to the negative 2nd power. So that's what we see here in this next step. And then when you take the negative 1/2, raise that to the negative 2nd power, you have a power to a power, so you multiply the exponents. Negative 1/2 times the negative 2, which would then become a positive 1, which is what we wanted. So we have y to the first power equals, and then 5 to the negative 2nd power becomes 1 over 5 to the positive 2nd power, which is going to be 1 over 25. And that is my solution. So the key here is raising both sides to the reciprocal power so that your exponent becomes a 1. Here's another example. You have x minus 2 raised to the 3 over 2 power. So same idea, but now we have parentheses thrown in there as well with the rational exponent. But same concept. To get rid of the 3 halves as the exponent, I need to raise both sides to the reciprocal power. So the reciprocal of 3 over 2 would be 2 over 3. So I raise both sides to the 2 over 3 power. So on the left side, I multiply the exponents, 3 halves times 2/3, which will give me just a first power. So I have x minus 2 to the first power equals 8 to the 2/3 power. So from here, I need to figure out what is 8 to the 2/3 power. Well, I can write that using radicals, and so I can have the 8 inside the radical. The 2 can either go with the 8 or outside of the radical, and the 3 is going to be your index. So here I have the cube root of 8, which is 2, and then square that to get 4. So I have x minus 2 equals 4, and then add 2 to both sides, and I'm going to get x equals 6. One more example. Here we have 4x to the negative 1/3 power equals 20. So I want to get x by itself, meaning I need to get rid of the 4 and the negative 1/3. Well, to get rid of the 4, I can divide both sides by 4. And now I have x to the negative 1/3 power equals 5. Then from here, I'm back to the last two examples where I just raise both sides to the reciprocal power to get rid of that negative 1/3 as your exponent. So instead of negative 1 over 3, I raise both sides to negative 3 over 1, or just negative 3. And on the left side, negative 1/3 times the negative 3 would become a positive 1. And on the right side, 5 to the negative 3rd is the same thing as 1 over 5 to the positive 3rd. 5 to the positive 3rd power would be 125. So my solution would be x equals 1 over 125. And that concludes our lesson for today. We will see you next time.